Hi Year 11, here's just a quick video looking through titrations as some quick revision before your exam this week. So first thing here, we're just going to look at the method of a titration. This is a really nice question I found. It sort of reflects the general kind of question you could get. So you're just being asked to describe how to use the apparatus to do a titration using 25 centimetres cubed of dilute hydrochloric acid. Key things to remember is how we're going to determine the endpoint. So that's going to be using an indicator. And they've labelled that indicator already in the picture. So that's great. Phenolphthalein, we don't even have to remember how to spell it, which is fantastic. And then how we'll make sure the results obtained are accurate. So that's where we need to think about the correct equipment to use. So pause the video now. Why don't you have a go at this question? 4 marks, so 4 key bullet points about how to do a titration, and then press play and I'll go through the answer with you. Quick thing to remember, as it's a titration, we're looking at a neutralisation. So they've told us that we're going to use dilute hydrochloric acid. So to neutralise that, you need a suitable alkali, and I would recommend going for sodium hydroxide. So make sure you include that in your method. Okay, so hopefully you've had a go right in the method, and I have too. And just to go through some key points for you. So first thing I've written is that you need to add the sodium hydroxide to the burette. Then you're going to measure 25 centimetres cubed of acid using a pipette. And this links back here to our making sure it's accurate. And add this to the conical flask. You're then going to add your 2 to 3 drops of indicator to the flask. Next, step 4, I'm going to read the start volume in the burette from the bottom of the meniscus. And remember, the meniscus is, if you've got your burette there, it's the curve that forms in the water, and we read from the bottom. We're then going to add alkali to the flask whilst swirling it. We're going to stop adding when the indicator goes pink, and that goes back to our accuracy, knowing when the acid's been neutralised. Record the end volume of the alkali and calculate the volume added, and then repeat to get concordant results. And remember, concordant means within plus or minus 0.1 of each other. You don't need all of those points. Usually for a question like this, you just need to mention 3 to 4 of the key points. So things like using a pipette to measure the acid, adding the alkali to the burette, adding an indicator, adding alkali to the flask while swirling, anything like that. Next question here, we'll explain why the student should use a pipette to measure the acid added to the burette. Explain why the student should use a pipette to measure the acid and a burette to measure the sodium hydroxide solution. So the reason that we use a pipette, as I've mentioned, is so that we can measure a fixed volume accurately. So it's more accurate than using a measuring cylinder, and a burette is used because this is really good at measuring a variable volume. So say our pipette would be for 25 centimetres cubed, and our burette, we can measure as much as we want. So next part, I just wanted to look at a little bit of theory about acids and alkalis. So they've said here, dilute hydrochloric acid is a strong acid. Explain why an acid can be described as both strong and dilute. So let's work on the strong bit first. So if we think back, we know that strong acids are fully ionised. Which I now can't spell, there we go. And remember that a weak acid would be partially ionised. And dilute tells us something about the concentration. So remember, concentration is measured in moles per decimetre cubed when we're talking about solutions. And so if something is dilute, it tells us that we've got a small amount of acid, or a small number of moles, per unit volume. So I'm just basically explaining those units that we've got there. Next thing, another bit of theory, is to do with pH. And so here we've got a concentration. So 1 times 10 to the minus 3 mole per decimeter cubed solution of hydrochloric acid has a pH of 3. So it's just saying, what is the pH if my concentration is slightly more dilute? So it's 1 times 10 to the minus 5 moles per decimeter cubed solution. And there's a really simple rule. So every time this changes, the power up here, so your times 10 to the power, every time this power changes by 1, your pH increases by 1. So going from times 10 to the minus 3, that's a pH of 3. So that decreases your power there, your times 10 to the minus 5, that's the number's getting smaller. So that means your hydrogen ion concentration has gone down, but all you need to remember is that it means your pH goes up. So because that's gone from minus 3 at pH 3 to minus 5, it's pH 5. If it was times 10 to the minus 4, then it would be pH 4. So that's a really simple rule. Scrolling through, right, let's look at the calculation. So student titrated 25 centimetre cube portions of dilute sulfuric acid with a 0.105 mole per decimetre cube sodium hydroxide solution. Lovely. So we've got our acid and our volume. If I change colour, we've got our alkali and our volume there. Sorry, I'm making stuff up now. We've got the volume of our acid and we've got a concentration of our sodium hydroxide. And then when we go to the table, we've got the volume of our sodium hydroxide here. We've got an equation for the reaction. We need to calculate the concentration of the sulfuric acid. So to use only the student's concordant results, and these are 0.1 centimetres cubed of each other. So let's go through the first step. Let's go through selecting our concordant results. I'm just going to highlight them here. So we've got our first titration, 23.5, 21.1. So I'm going to ignore this one and ignore this one. They're not concordant with anything. But here we've got 3 results that are all within plus minus 0.1 of each other. So there are concordant results. So I'm only going to use those to work out my volume of sodium hydroxide. So why don't you, if you want to challenge, pause here, have a go at working through this problem and come back and I'll work through the answer with you. If you want to hang around just for a little bit longer, I'll show you how to lay out your calculation and then you can pause it there. Okay. So first thing I'm going to do, I'm going to write out the equation a bit bigger, and we can totally ignore the products. Oh, I don't know why I'm on that one. Totally ignore the products here. They don't matter at all. We only care about those reactants. So 2NaOH, add our sulfuric acid. Now, the really important thing to note here straight away is that for every 2 moles, our ratio, every 2 moles of sodium hydroxide, it's only, remember you've got your imaginary 1 mole, I'm going to put it back in, 1 mole of sulfuric acid. So that ratio is really, really important. Okay, right, and then we lay out our table. So we do volume. Don't forget this needs to be in decimeters cubed. We do our concentration. We do our mole. And we do our ratio. Nice and simple. So let's just go back. So you have to pretend I've calculated this here. So I've done my volume of sodium hydroxide. So I've added these 3 things together and divided by 3 to get my average volume of sodium hydroxide, which is 22.13 centimetres cubed. And to convert that to decimeters, I'm just going to divide it by 1,000. So I'm just going to delete that to make a bit of space. So that gives me 0.02213 decimeters cubed. My sulfuric acid, if I scroll back up, that was in the question. That was 25 centimeters cubed. Divide that by 1,000 and we've got our volume of our sulfuric acid. Concentration sodium hydroxide in the question again, 0.105. Okay. And remember, moles is concentration times volume. So I'm just going to multiply those 2 numbers together to get my moles of sodium hydroxide, which comes out at 0.002 2324. Okay. Then we've got our ratio. So going back to what I was talking about at the beginning, for every 2 moles of sodium hydroxide, I'm only going to use 1 mole of acid, and that is because there's 2 hydrogens present in that acid. It's not super important now why that matters, but just know, use these big numbers in front just to make sure that you've got your ratio right there, 2 to 1. So then I know that for every 2 moles, I need 1 mole of my acid, so I'm going to half the moles I've calculated here. I'm going to divide this by 2 to get my moles of sulfuric acid, sulfuric acid, and so that is 0.001162. And then I want to work out concentration, and concentration is moles divided by volume. So I'm going to do my moles here divided by my volume that I use for my titration, and I come out with the answer of, I'll change colour so it's more obvious, 0.0465. And that's all I needed to do, calculate moles. So there was an answer line, but I've deleted it. But on the answer line, if I had moles of H2SO4, sorry, that's a complete lie. Concentration of H2SO4 is 0.0465 moles per decimeter cubed. Nice. So remember, volume concentration, calculate moles. First step in any calculation, find the moles. Use the ratio to get moles of our acid and work backwards from there. Last question then I've got for you here is calculate the mass of sodium hydroxide in 30 centimetres cubed for 0.105 mole per decimetre cubed solution. And they've been very nice and given me the relative formula mass of sodium hydroxide. So first thing in any calculation is calculate the moles. Remember, moles is mass over mR. Moles is also concentration. Concentration times volume. I don't need that. Delete. I'm waffling. I apologise. No, I do need it. Oh, devastating. Let's do this one again. So moles is concentration times volume. I've got a concentration. I've got a volume, which I'm going to convert to decimeters cubed. So that gives me my moles, which is 0.00315. So that's how many moles I've got. And then I'm going to do mass is Mr. Moles. So my MR is 40, given it to us in the question, times my moles from earlier. And then I can work out my answer, which is 0.126 grams. Nice and straightforward, even though I made it look hard there. Okay, that's nearly it from me, but I just wanted to say a massive good luck for your exams this week. You'll be absolutely fabulous. You're all wonderful people. So take care and good luck.